apply these limits to the answer, the integration, we will have a function with omega, no? We will have a function with omega. Okay, so you can see then, if we see the surface, if we look at the surface, you can see that first this signal is in t, the independent variable is t, then we convert it to the function with the independent variable omega. Okay, so this omega is angular frequency. So you can see that we have convert this time domain signal. Time domain means independent variable is time. Okay, this is varying according to the time. Then we convert it to the frequency domain signal with omega. This independent variable is omega. Okay, so if you want to convert it to f, that means frequency. This is angular frequency. If you want to convert it to frequency, you know the relationship with omega and f, that is 2 pi f. Okay, so you can use this and convert it to the f. Okay, so this is time to frequency transformation if we look at the surface. Okay, so and you have the inverse Fourier transform. That means you are converting the frequency domain signal into time domain again. Okay, so we have a frequency domain signal. Okay, this frequency domain signal we have, then we convert it to the time domain. Okay, so we called it Fourier inverse transform of x omega. This is capital X, no? Omega. So you will have 1/2 minus infinity. I think someone speaker is on. Please. Okay, I think it's okay. So you have this again back to time transformation. That is, you have to integrate this x omega. This is frequency domain signal. Okay, into j omega t. This should be plus j omega t. No, it is with omega. Okay, so when you do this integration and apply the limits for this omega, this is the independent variable of this function omega, you will get the function with t again. Okay, so basically here we are doing converting this omega into t. Okay, so this is the Fourier transform for aperiodic signal, and this is the inverse Fourier transform of the aperiodic signal. Okay, so we will go to this one. Okay, so we have xt is equal to e minus a t. Okay, so this is magnitude t. Okay, this is absolute value of t. Okay, so if we try to draw this signal, so how can we draw it? Okay, so you can see that so you know, if we get e minus at signal, okay, without absolute value, okay, so you have, these are the minus value, this is minus infinity and this is plus infinity, you will get this kind of graph, no? Okay, gradually it is reaching to 0 at the plus end. Okay, so we see it in Matlab. Okay, so if we want to get this signal, okay, this signal we will get yeah, this kind of signal, no? So you can see that here it is at 0, it is 1. At 0 it is 1, no? You can just have idea. Okay, so here I draw the signal EAT. Okay, here I draw, here I have drawn the signal E minus AT. Okay, E minus AT, no? Yeah, E minus AT from -1 to +1. Okay, so we will get, here I draw the signal from -1 to +1. So we will get this kind of signal. Okay, E minus AT. Okay, so you can see that if we consider this absolute value, okay, so if you consider this absolute value, so this is not changing for plus value, no, the for plus t, this part is not changing. Okay, because absolute, if you get the absolute value of say +1, +2, +3, like this. Okay, so if you get t is equal to +1, if you get the absolute value, you will get again 1 +1. Okay, if you get t is equal to +2, if you get the absolute value, it is again +2. No, so for plus value, okay, so note that for plus value of t, okay, for plus value of t, this is plus value of t. Okay, t is equal to absolute t. Okay, no change. So for the plus value, for 0 to plus infinity, okay, this will get the same result. Okay, this absolute value will get the same result. Okay, so try to understand it. Okay, so I will draw this somewhat clean. Okay, so we have a signal like this. Okay, so we have a signal like this. Okay, so here it is 0, it is at 1. Okay, so you have here, let's say +1, let's say +2, let's say +3, +4. You will get this kind of graph. Okay, so for t is equal to absolute t, for plus side, from here to here, this side, okay, the same function you will get. Okay, 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 so let's consider the minus side. Okay, so let's consider the minus side. Okay, let's take, this is +1, this is +2, +3, like that. Okay, okay, so what about the minus value, minus side value? Can anyone think of it? So how it look like? Can anyone imagine? Okay, so we will see what happened to the minus side. Okay, for minus value, for minus value, for minus value of t, for minus value of t, what happened? Okay, so if you get the, here these are minus. Okay, so these are minus, -1, -2, -3. Okay, for minus value of t, what happened? Okay, what is happened there? So if you get the, if t is equal to -1, okay, so t is equal to -1, this point. Okay, what happened? If you get the absolute t, okay, that means you have to get the absolute value of -1. That means you will get +1. No, so at this point, at this point, at -1 point, okay, if you get the absolute value, okay, so you will get again -a1. No, correct? If you get, you will not get -a -1. Okay, you will get minus A1. Correct? Okay, so you will get this value here. Okay, so you will get this same value here, no? For minus side, not this value, not this value. You will get this value here. Okay, so if you get minus plus 2 value, so try to understand this. Okay, so if you get minus 2 value, if t is equal to minus 2, that means this point. Okay, this point. Okay, if you get minus 2, then xt then xt equal to e minus at. This is our function. Okay, so if you get minus 2, okay, here minus 2. Okay, so if you get the absolute value, if you get the absolute value of t, okay, that means absolute value of minus 2, you will get again plus 2. Okay, so here again you have not minus 2, okay, you have plus 2. Okay, so that here this point also equal to this point, no? This point. Okay, and same if you consider the minus 3, again you will get the absolute value and you will get plus 3. Then it is a minus plus 3, not minus 3. That means you will get this value. Okay, you will get this value at minus 3. Okay, okay, so this is you will get at minus 1. Okay, and this value you will get at minus 2. So at minus plus 4 value you will get also at minus 3, and plus 4 value you will get that minus 4. Okay, like this. So 0 it is same, and you will get this kind of graph, no? This kind of function. Okay, not this. Okay, so you will get this kind of graph, no? Correct? Okay, so what is this part? So what is this part? This is EAT, no? This is EAT. Okay, because minus, if you consider the e plus 80 function, okay, if you consider the e plus 80 function, it is look like this, no? It is 0 at here. Okay, so this will be the EAT plus EAT, not minus 80. Okay, so understand. So to get the better understand, let's see at the Matlab. Okay, so if I plot plus 1, okay, so I will comment this. Okay, so I think now I no need to explain these things because we have done Matlab session. Okay, so I think now you are somewhat familiar with this code. Okay, so here it is very simple code. I'm just trying to draw this signal in Matlab. Okay, to get the better idea about the signal, actually to verify our answer. Okay, okay, so if we draw the signal with t minus a2, here I draw the signal t minus 1 to plus 1 with 0.001 step. Okay, so I will have, so I am going to plot e plus at, e to the power at value. Okay, so here so here minus a to plus a, sorry, here some plot is there. So this kind of function we have, no? Okay. So if you compare this value, okay, this value, you will get the same value. Okay. So try to draw it in Matlab and try to get this answer verified. Okay. So finally, we will have this kind of function. Okay. This kind of function. Okay. This is t. This is e to the power minus or plus. E to the power minus. No? E to the power minus absolute value of t, not t. So you will get, if it is 1 and this is 0, you will get this one like this, and again you will get like this. Okay, so this part is equal to e minus at, and this part is equal to e plus at. Okay, so you will have this kind of graph if you draw this e to the power minus a absolute t. Okay, so you should be able to draw this kind of graph. Okay, so if you see it in Matlab, okay, so you can see that. Okay, so I graph from 0 to, no, from 0 to 1. Okay, if I graph 0 to 1, e to the power minus at, and this should be minus 1 to 0, no, minus 1 to 0. Okay, that means here 0 to 1, 0 to 1. Okay, 0 to 1, I can't put infinity at Matlab. That is why I draw it up to 1. You can draw it up to 2, 3, any value. Okay, so I am draw it up to 1 only. So it is minus 80. From 0 to 1, it is minus 80. And here, this part I draw from minus 1 to 0. Okay, from minus 1, 0. So it will be e to the power plus 80. Okay, so I am going to draw only this part. Okay, only this part from minus 1 to plus 1. Okay, but the actual signal is there from minus infinity to plus infinity. But in Matlab, we can't use this infinity value. That is why I limit my graph to plus 1 and minus 1. Okay, so don't get confused. Okay, this thing. Yeah, I can explain. The problem is that this 1 hour I couldn't do that because I have to upload. But after 3 o'clock you have another lectures, no? ඔකට්ටේට වෙන lecture එකක් තියෙනවනේ නේ. 3ට පස්සේ ඒක බලමු අපි මොකක් හරි solution එකක් දාගන්න බලමු. එහෙම වුණොත් පැය භාගයක් විතර අපි වෙන දවසක හරි අරගෙන පොඩ්ඩක් බලමු මේ තව ටිකක් මේක verify කරගන්න. හරි. දැනට මම මේක conduct කරන්නම් ඉංග්‍රීසි වලින්. මොකද අපි ඒක කරන්න ඕන ඒකෙන් අප්ලෝඩ් කරන්න ඕන හින්දා සිස්ටම් එකට. ඕකේ. බලමු කොහොම හරි මේ දැන් තාම පටන් ගත්ත විතරනේ මේ පොඩ්ඩක් ලබන සතියේ දිහාට බලමු මොකක් හරි සොලියුෂන් එකක් හදාගන්න පුළුවන් වේද කියලා. Okay, so I will continue. Okay, so here so if we see at Matlab, okay, if we see at Matlab, so here you can see that I am drawing 0 to 1, this e to the power minus 80, and minus 1 to 0, e to the power plus 80, as I told in that graph. Okay, so we will get yes, we will get this. This is plus 80, e to the power plus 80 graph up to 1. Okay, minus 1 to 1. Minus 1 to 0. Okay, and this is 0 to plus 1, that is e to the power minus 80 graph. So we will get this kind of graph. Okay, so our graph is correct. Okay, so we have finally this kind of graph. Okay, so I just use Matlab to show you. Okay, so we will use that Fourier transform pair. Okay, so this is called Fourier transform pair. Okay, this is called Fourier transform pair for periodic signal. The Fourier transform and inverse Fourier transform. So we are asked to find the Fourier transform. Okay, we are asked to find the Fourier transform. So we have to use this one, Fourier transform, first term. Okay, so we have, okay, so we have when xt, okay, when xt is converted to Fourier transform, if we get the Fourier transform, not inverse, okay, if we get the Fourier transform of xt, okay, Fourier transform of xt, we will get x omega, capital X omega, and we have minus infinity to plus infinity xt j omega t dt. Okay, so here xt is, we have three parts. From minus infinity to 0, it is EAT. So I will do this integral in two parts, from minus infinity to plus 0. So minus infinity to 0, it is e to the power plus 80. Okay, so e to the power plus 80. Okay, and we have e minus j omega t. Okay, plus here this part. Now we consider this part. Okay, now we consider this part, and also we have to consider this part. No, so you can see that this period, this signal is not periodic. No, this is a periodic signal. The signal is not repeating. Okay, so this is a periodic signal. Okay, so we can find the Fourier transform. Okay, so we have from 0 to plus infinity, the xt is e to the power minus 80, e minus j omega t dt. Okay, so this integration we have to do. Okay, so x omega is equal to, here minus infinity to 0, so you can see that we can write this term here. Both have the variable t. Okay, but we can write it in one terms, with one term, 0 to 1. Okay, e to the power, this t is common. Okay, if you get the t, you will get a minus j omega. Okay, plus from 0 to plus infinity, you will get, if you get minus t, okay, if you get minus t, if you get minus t out, so you will get a plus j omega. Okay, here it is dt and here it is dt. Okay, then we can easily integrate this. Okay, so you know, if we integrate this exponential term, you will get the same term, and it is divided by this constant. No? So this is the constant part. And we have to divide this term with the constant a j omega. Okay, so we have this term is infinity to 0 plus, if we integrate this term, so you will have the same term a to the power j omega, a to the power e to the power minus t a plus j omega, divided by, you have to divide it with this constant. No, that means here you have to consider the minus value, minus a to the power j omega. So this is from 0 to plus infinity. Okay, so we see what happened. Okay, so we see what happened when you apply the limits to this terms, these two terms. Okay, so first we substitute the upper limit. This is the upper limit, and then we substitute the lower limit. No, this is the lower limit. Okay, so if we substitute this upper limit and lower limit, okay, you will get here it is 0, t is 0, then you will get 1. So you will get 1 a to the power a minus j omega minus, if you apply minus infinity, okay, minus infinity, okay, what is the minus infinity value? So this graph, now we are considering this part, this part. So what happened? This when this graph is going to minus infinity, okay, minus infinity, what happened? Okay, this e to the power minus at will reach to 0, no? So at minus infinity, this will be 0. Okay, so here at minus infinity, if you apply this minus infinity, the lower limit, the value will be 0. Okay, and if we consider this one, okay, so here we have the minus sign. Okay, we will consider that's minus 1 also. Okay, so you will get, you have to apply this upper limit, that is infinity. Okay, so plus infinity. No, so if you consider this graph, this line, okay, if you consider this part, this line, what happened when the t is reached to plus infinity? This xt will reach to 0, no? When t is reaching to plus infinity, the xt, that means e to the power minus at, okay, that is reaching to 0, no? Here, when the t is reaching to minus infinity, xt is reaching to 0, minus infinity. This part you can see here, okay, and here it's reaching to 0, no? Okay, it's reaching to 0. This when t is reaching to plus infinity, xt, okay, this is xt, okay, this is xt, the graph, okay, the signal, that xt signal is reaching to 0. Okay, so here we have 0 minus, okay, so if you apply this lower limit, this e to the power 0, that means 1, no? So you will get 1 by a plus j omega. Okay, so you will have this two variable. So if you simplify it much longer, you will have these two terms, a plus j omega, this minus and minus, you will get plus again. Okay, not minus. Okay, so you will get plus value. So you can get this as the lower part. Okay, so you will get a minus j omega, a minus j omega, a plus j omega, and you will get here a plus j omega plus a minus j omega. Okay, so j omega cancel out, and you will get 2a. Okay, you will get 2a, and if you, I think you can simplify this term also. Okay, so it will get a square minus j omega square. Okay, you know that j square is minus 1. Okay, j square is minus 1. If you get the j square, it is minus 1. So you can remember that minus 1 root is equal to j. No, this is the definition of the complex numbers. Okay, so if you get the j square, you will get minus 1. Okay, okay, so with this part, with this, you can see that it is 2a plus, here j square, means -1. So minus -1 means +1. So you will get a square plus omega square. So you will get this value finally. Okay. So this is the x omega. Okay. So you can see if we get xt Fourier transform, we will get x omega, and x omega is equal to 2a square plus omega square. So you will get this function. And if you want, so this is somewhat complex, you can't draw it directly. Okay. So but in Matlab you can draw it. Okay. So here I have drawn it. Okay. So this is my xt. Okay. So I get this a as 2. Okay. I get this a as 2a is equal to 2. You can get any value. So if we draw the signal, so you will get this kind of signal. Okay. This will be -1 to 1. Okay. So you will get this kind of signal. Okay. So you will get this kind of signal. Okay. So I hope that Dr. Udesh will cover the property also. Okay. So after doing the property, Fourier transform property, we will see this question. Okay. So I will do another question. Okay. So let's see. Okay. So you know the delta t function, no? The impulse function, a Dirac delta function, delta t. Okay. So you have learned about this signal. Can you see? Can you remember this signal? Okay. So this is so delta t. Okay. So this signal is look like this, no? I think you can remember maybe like this. No. So it is 0, it is going to infinity. Okay, at 0, it is going to infinity. So this is a special function. So this is a special function. Delta t is a special function. Okay. So if you want to find the Fourier transform of this delta t, if I ask you to find the Fourier transform, find the Fourier transform of delta t. Okay, so let's see how we can do this. Okay, so how can we do this? Okay, so I think you should keep remember the property of this delta t function. Okay, so one property is if we integrate this delta t function from -infinity to +infinity, okay, normally it should be a value of 0. Okay, because here only 0 point. Okay, normally it should be a value, the value should be 0, but this is not a normal function, it is a special function, and the answer is here 1. Okay, so this is a property of delta t function and also a definition. Okay, and there is another property. Okay, if you multiply this delta t function with another function, any function, periodic or aperiodic function, okay, and if you integrate it to -infinity to +infinity, you will get the value of 5, 0. Okay, so t is equal to 0. At t is equal to 0 value, you will get as the answer. Okay, so these two are the property of delta t function. Okay, and I think it is better to keep remember this two property of the delta t function, because this is very useful. Okay, so here also you can see that these are the two, you know, this is first property of a delta t function, and this is the second property of the delta t function. Okay, so this property and this property you have to keep remember. I think you have learned these things, no? We have, when we are finding the Fourier series of delta t function, we use this same property, no? I think you should remember. Okay, we have used this same property to find the Fourier series of delta t function. Okay, so here, so keeping this property in mind, okay, we can try to evaluate this Fourier transform of this delta t function. Okay, so if we are going to evaluate the Fourier transform, okay, if we are going to evaluate Fourier transform of delta t function, okay, so we are going to evaluate Fourier transform of delta t. Okay, so we will get definition minus infinity to plus infinity. Okay, we have delta t e minus j omega t dt. Okay, so this is the definition of Fourier transform, no? So this is the xt. Normally this is xt. Now our xt is equal to delta t. Okay, that is why I directly substitute this del t here. Okay, so this is the definition of Fourier transform. So we have to evaluate this, no? Okay, so we have to evaluate this minus infinity to plus infinity delta t e minus j omega t. Can someone tell me the answer? I think now you should be able to tell the answer. What is the answer? So what is the answer of this integral? I think now you should be able to tell me the answer. What is the answer of this? Okay, so look at this property. Simply look at this property, this definition of a delta t function. Okay, so if you evaluate the integral delta t phi t, you will get phi 0. So t is equal to 0 value. Okay, so what is the value of here? So this is delta t and this is phi t, no? This is the phi t. Okay, so you will get the answer as phi 0. Phi 0, that means you have to substitute 0 to phi t instead of t. Okay, so if you, so this is our phi t. Okay, so this is our phi t. Okay, so if you substitute the 0 to this phi t, what is the value? E to the power minus j omega 0. No, that means e to the power 0. And what is the answer? 1. Okay, so if you evaluate this integral, you will get the answer as 1. Okay, so if we consider the Fourier transform of delta t function, Fourier transform of delta t function, we will get 1. Okay, so this I think better to keep in your mind. Okay, So another point I think it is better to point out. Okay, so if you consider, if you want to find the Fourier transform of AT. Okay, so here it is not absolute value, only AT. So you want to, okay, so another answer, okay, another one, okay, another one. So we want to find the Fourier transform of e to the power AT. Okay, so how can we find this? How can we evaluate this? Okay, so you can simply use the principal method. That is, we can use that transform pair. Okay, that is Fourier transform of xt is equal to x omega and minus infinity to plus infinity xt e to the power minus j omega t dt. So this identity we can use. Okay, so if we use this one to this one, you will get x omega is equal to minus infinity to plus infinity. Okay, minus infinity to plus infinity. Here xt is EAT, so you will have EAT e minus j omega t dt. Okay, so you will have minus infinity to plus infinity e to the power. Okay, this t is same for 2. Okay, this t is same. Here it is j omega. Let's take as j omega. Okay, sorry, e to the power j omega. Okay, e to the power j omega. Okay, and we will have, okay, this, if we get this jt out, okay, we will have a minus omega. Okay, sorry, we will consider the AT. Okay, not the complex exponential term, just the exponential value. Okay, e to the power AT. Okay, e to the power AT. Okay, so if you consider the Fourier transform of this, okay, e to the power AT here. Okay, so you will get, okay, you will get minus infinity to plus infinity e. Okay, so here t you can get out. Okay, then you will remain a minus j omega dt. Okay, so we can easily integrate this, no? So we can easily integrate this. So we can easily integrate this. How can we integrate? So x omega is equal to minus infinity to plus infinity. Sorry, I will integrate this. X omega is equal to, when integrate, we will have e to the power t a minus j omega, and you have to divide it with this constant, no? A to the power minus j omega minus infinity to plus infinity. Okay, so you can do the so you can see, you can do the integration very easily, but you have to find these limits. No, you have to apply these limits. What happens when you apply these limits to this signal? Okay, so here you will see that if we consider EAT signal, it is just like this. No, it is just like this. Just now we have seen it. Okay, so here minus infinity, it is 0. Okay, and plus infinity, it is infinity. No, it is infinity. But when we consider that e minus a absolute value t, we have, okay, 0 to plus infinity like this, and minus infinity to 0, it is like this. Okay, and when at the point of 0, it is equal to 1. Okay, but if you consider this EAT signal, without the absolute value, if you consider this EAT signal, okay, so this signal is look like this, no? Okay, so minus infinity it is 0, plus infinity it is again infinity. Okay, so if you substitute these limits, okay, these limits to the uh, to the to this term, you will get, okay, you will what you will get, okay, so minus infinity, when you apply plus infinity, you will get infinity, the value is infinity, and at minus infinity, you will get the value is 0. Okay, so you will get infinite value, no? Infinity minus 0. So you can't actually evaluate this integral with limits. Okay, so so you can see that if you are given EAT and you are asked to find the Fourier transform, it is not possible to evaluate it directly, no? Because you can't find the limits here. Okay, understand? Okay, and also if I ask you to find the Fourier transform of this kind of signal, this is, say this is 1 from minus infinity to plus infinity, so this is signal xt is equal to 1. This is the signal. Okay, so if we consider this kind of signal, xt is equal to 1. Okay, so if you draw the signal, it will look like this. No, it is a DC signal. DC component is only there. Okay, okay, so if you are, so this is the okay, so this is our signal. So if you ask to find the Fourier transform, okay, so if you are asked to find the Fourier transform of this kind of signal, so there is a limit, no? There is a finite limit, minus 1 to plus 1, no? Minus a to plus a. There is a finite limit. So you can do that integral. Okay. But if you ask to find this, find the Fourier transform of this kind of signal, minus infinity to plus infinity, again you will face the same problem. Okay. So if you want to find the Fourier transform, you have to get xt, that is 1. Okay, e to the power j omega t from minus infinity to plus infinity dt. Okay, this is the Fourier transform of 1 definition. No? Fourier transform of 1. This will be the definition. Okay, so if you going to evaluate this, you can do the integration very quickly. You will get j omega t and minus j omega. But it is minus infinity to plus infinity. But when you are going to apply these limits, again you will face a problem. No? You can't evaluate that integral correctly with limits. Okay, so this kind of question, we can't directly find the Fourier transform. That is why we are learning about Fourier series property. Okay, so if so still you are not you have not learned that property, but after learning this property, you can do this kind of question. So we will see it in next uh, next week. Okay, so we will stop here.